Have you ever tried solving an equation like this? If we try to isolate x by subtracting 1 and then take the square root of both sides, we get this, the square root of -1. So what is the solution? You've probably been told that this doesn't exist, as no real number equals the square root of a negative number. So does x exist? Not in the world of real numbers. But what if we invented a number that equals the square root of -1? Say hello to I, the square root of -1. This number can't be plotted on a real number line. It's not positive, not negative, and not 0. It's imaginary. But that doesn't mean it's fake. It means it's a whole new dimension of math. I is a very interesting number. Since I equals the square root of -1, if we square this, since any square root times itself is what's inside, we end up with -1. I squared equals -1. If we cube I squared is -1, so we get the negative square root of -1, which is -I. And if we raise I to the power of 4, the square root of -1 times the square root of -1 is -1, and -1 times -1 is 1. So we went from I to -1 to -I to 1. This pattern repeats every 4 powers. I to the power of 5 equals I to the power of 6 equals -1, I to the power of 7 equals -I, and I to the power of 8 equals 1, and so on. Okay, cool, but why is I important? Why does this even matter? Although I sounds like pointless imagination, I helps us solve equations that we couldn't solve before. It shows up in engineering, physics, computer graphics, signal processing, and so much more. Without I, certain types of wave equations and electrical currents would be impossible to understand. MRIs and GPS all depend on I. So even though it's called an imaginary number, I is actually super important. Now, the cool thing is, I can also be combined with real numbers. These numbers are called complex numbers. All complex numbers follow the simple form a plus bi, where a and b are real numbers. A is the real part of the number, and bi is the imaginary part. Together, they form complex numbers. Complex numbers behave just like other numbers. You can think of the I as a variable. To add or subtract complex numbers, we just combine like terms, like solving for algebraic expressions. When multiplying complex numbers, we use the FOIL method, just like when multiplying binomials. In this example, after we expand the multiplication, we can simplify by combining the i's. And since we know that I squared is -1, we can also combine the real numbers, giving us -29 plus 2i. To divide complex numbers, we need to multiply the numerator and denominator by the conjugate. In this example, to get rid of the I in the denominator, we'll need to multiply by the conjugate of the denominator, 7 minus 4i over 7 minus 4i. After expanding, we get this. We can then simplify by combining like terms. In the denominator, like we intended, the -28i and 28i cancel out. In the numerator, 116i plus 14i is 130i, and I squared is -1. So now we can add the real numbers together. -203 plus 8 is -195, and 49 plus 16 is 65. To get this into simplified form, we'll need to separate the real part from the imaginary part of the complex number. Now we can simplify a bit more. -195 over 65 is -3, and 130 over 65 is 2. So we're left with -3 plus 2i. Now, how can we plot complex numbers? We know that we can't plot complex numbers on a regular number line. Similar to an xy plane, we can create a complex plane. The horizontal axis is the real part, and the vertical axis is the imaginary part. So to plot 3 plus 2i, the point is 3 units to the right and 2 units up. And similarly, -3 minus 2i means 3 units to the left and 2 units down. Using the complex plane, we also notice something very interesting about I. If we start with 1 and multiply by I, we get I. Easy. Now, if we multiply by I again, we get -1. Multiply again, and we get -I. And if we multiply by I once more, we've circled back to 1. We've just rotated in a full circle. Every time we multiply by I, we rotated 90 degrees counterclockwise. Thus, similar to trigonometric functions, I is essential in wave functions, rotations, and oscillations. And all of this comes from the square root of -1, the imaginary number which we call I. In this video, we've seen how the powers of I repeat every fourth time, how complex numbers are in the form a plus bi, how we can use the complex plane, and how multiplying by I rotates 90 degrees. Although we call it imaginary, I unlocks a deeper, richer world of mathematics. Imaginary numbers aren't fake. They're a new way to see the true beauty of math. So that's a quick dive into I, the imaginary number. If you enjoyed this video or learned something, don't forget to leave a like, subscribe, and share it with any friend who thinks I isn't real. In the description, you can also find a link to a compiled list of recommendations I have, which you should check out. Now, keep working hard and keep learning. Thank you for watching.